Okay, so today we are going to start logarithms. It's a very important chapter. No many there are no many direct questions from this chapter, but the concept is very easy, and you can expect one or two questions from this chapter, and as well as it is very much it it form a basis for mathematical operations, and so this is going to be important for other chapters also, as the UPSC India trend is changing, so questions can be asked in a mixed format, mixing some concepts, so it's a really important concept like trigonometry. Okay,
Yeah, sir.
so logarithms. So before logarithms, we studied law of indices in yesterday's class. Do you remember them all?
No, sir.
No need to remember them also. Just have to understand it. So it
Okay.
means that A was getting multiplied for n times. And if it is the scenario m plus n, so it can be written as am is a raised to power m is getting multiplied by a raised to power n. And when we are writing a raised to power x, it can also be written as a raised to power minus of x. Or if there is a raised to power minus x in the power, so the sign will change when it go in the denominator or in the numerator from its original place. And so similarly, a raised to power m minus 1 can be rewritten as a raised to power m upon a raised to power n. Clear?
Yeah, sir.
Yeah, so these kind of law of indices we were discussing. So let's now tell me 3 raised to power 4 is what? How do we calculate 3 raised to power 4? We'll have to multiply 3
3 into 3 into 3 into 3, like 4 times.
4 times. And that comes out to be 9, 3 are 27, 3 are 81. Right? So 3 raised to power 4 is 81. Now, this is the base. This is the exponent. This is our result of this exponential function, right? So here, what we were doing in an exponential function, we were finding the result uh, of when some base gets some power, when some base is raised to some power. But in logarithm function, how we will write this? That logarithm base 3 and power 4, sorry, power 4 here, and its answer is 81. So what we are answering in logarithm, that to what raised to power 3 is 81. To what power is 3 raised to be become 81. That's the question we are answering, logarithm function that we are finding. In here, this is going to find this question mark so that it gives 81, right? Our result of the logarithm function here is the exponent. And in exponential function, we were finding the value when some base is raised to some power. Understood?
Yeah, sir.
Yes. So let me give one more example, that if there is a base A is raised to power n, and the result is coming as b. Okay, so this is an exponential function, functions expression. But when we have to write it in the format of logarithm, then a function, the logarithm function will give the output as the power. To what power should A be raised to give B? That's the question which our logarithm function is answering. Understood? That what use do logarithm have?
Yes, sir.
That basically tells to what raised to power A should be raised to so that it gives B. And this is answered by logarithm. This is here n. Correct? Understood?
Sir.
So let's read the definition. What was so if thus a raised to power x is m is becoming m. So logarithm of a to the result so that what raised to power a should be raised so that it becomes m. So m will be written here and x will be written here as a result. X will be a result, and which is what? It is an exponent to the base e. To the base a, sorry. Okay. So a raised to power x, we can represent it as logarithm a m is equals to x. Okay. So the base, which is a, is a positive real number. What are real numbers? Real numbers are a collection of all rational numbers and as well as irrational numbers. But basically, all real numbers which are real numbers which exists. Okay, that's it. And rational numbers are what? Rational numbers, sorry. Rational numbers are those numbers which can be represented in p by q form, where p and q are integers and q is not equals to 0. And those numbers which cannot be represented in the given format are termed as irrational numbers simply. And the union of both is real number, is the set real numbers. So now if a positive, if they a is a positive real number, a is here our base, is positive real number other than 1. Why not 1? We'll discuss it. And a raised to power x is m. Then x is called the logarithm of m. Logarithm of m to the base e. Learn this term. Logarithm of m to the base e. How we will read this? Logarithm of 27 to the base 3. Okay.
Yes, sir.
So this is asking that what should be the power of 3 so that it becomes 27. So what will be its value? Come on, tell.
3 to the power 3.
Yes. So 3 should be 3's power to become 27. Okay. So now coming back, now discussing the conditions. Okay. Discussing the conditions which is given in the other definition, that a raised to power x was m, logarithm to m, logarithm of m to the base a is x. Now the condition was that a is a positive real number. So a is greater than 0. Okay. And it is also a condition and a must not be equal to 1. So this is the condition for logarithm function. And now let's consider the scenario. Let's solve for 2 raised to power 4 is equals to 8. It will be written as logarithm of 8 to the base 2 and its answer is 4. So if we take a as negative, our function simply not work. So that's the reason behind this condition. Now, why a should not be 1? That if we take 1 raised to power 4, it will still come out as 1. So no matter what, so what we are, how we can represent this? Logarithm of 1 to the base 1. So what the answer should be? If we think for an answer, so this hypothetically, if we were to write logarithm function to the base for a1 also, then we will not be able to find out its exact value. Why so? Because think of it. What is logarithm? What is this says? This particular logarithm function is saying to what power of a to what power should a be raised to become x, right? Do you agree that the logarithm function is asking this question? If there
Yeah.
is anything I can clear, I can repeat. Yes, Tanish and Yashini.
Yeah, sir.
Yeah. So basically, logarithm function, there was an exponential function in this format. Then we can further write it in this format of logarithm of m to the base a. So basically, logarithm function answers us to what power should the base be increased to give m, and that is the power. The x is the exponent here, which was here. So this is to find x, we need logarithm function. That's the significance of logarithm function. So logarithm function here is asking to what power should a be raised to become to become x, to become m. Okay.
Yeah, sir.
Yeah. To what power, because x is itself at power, so we are just discussing about the left hand side of this given or this written expression, sorry, equation. Yeah. To what power should a be raised to become m, and the answer would be x. The answer would be the exponent. So now here hypothetically considering that the if the power, we were to discuss the logarithm function of logarithm of to the base a 1, then what is happening? Then we have to represent this in this format, because the result is 1, m is 1 here, and the base a, that is a, the base is 1. So now what is this questioning is to what power should 1 be raised to become 1. So 1 raised to power 0 is what? Answer?
Uh, it, which is one?
Yeah, so what is 1 raised to power 0 is?
1.
What is 1 raised to power 1 is?
1.
What is 1 raised to power 2 is?
1.
What is 1 raised to power 3 is?
1.
So 1 raised to power n will become 1 for all n belongs to real number. Sorry, my bad. Integers.
Integers.
Yeah. So now considering this fact that there are multiple like the n's value, its answer can be all integers, and it is a function which ideally be giving one answer. So that is the reason we do not it's of no use to apply logarithm or to the base of 1. So that is the reason that we are excluding this condition. Okay, understood? So this is the condition which was given. So now reading our definition back, if a is a positive real number other than 1, then x is called the logarithm of m to the base e. Logarithm of m to the base a. Logarithm of m to the base a, and the answer which it will be giving will be the exponent of x. Sorry, will be the exponent of a, which is x here. Clear?
Yes, sir.
Yeah. So let's now discuss this. If x is less than 0, if the power is zero, then logarithm of ax is imaginary. Okay, so this is not in context to the given condition. So let's discuss it on the next page because it will confuse you only. We will discuss this on next page. Because they have changed their assumption terms. It's better to discuss on next page. So the first condition here, logarithm of a to the x. Now here x is not the exponent. So considering this will equal to, let's say, b. So what is written here is a raised to power b is x. Okay. So now a logarithm of x to the base a will be imaginary if x is negative. Okay. So it means that that x is negative here. So x will be negative only if a is negative. Only if a will be negative. Understood? Why? Like, let us consider a scenario. 2 raised to power anything will always give some positive finite value. 2 raised to power anything. Maybe it is 2 raised to power 2. It is 4. 2 raised to power minus 2. It will be 1 by 2 raised to power 2, which is 1 by 4, which is still positive. Correct? Understood?
Yes, sir.
Yeah, so 2 raised to power anything will always give positive value. If we take base as negative, minus of 2. So the all the odd powers will give some negative value. So for any output of exponential function to be negative, the base has to be negative and the power should be odd. Then only the answer, the exponential function's answer will be coming out as negative. So when x is negative, then it is an imaginary logarithm of a of x is imaginary. Its solution does not exist. Imaginary means. And if x is equals to 0, so the logarithm of a of x is meaningless. So is this point clear, everyone? Then we'll come. Then we'll go on to discuss the second point. Is the first point clear? I'll repeat if not.
No, clear, sir.
Clear?
Yeah, sir.
Great. So let's now discuss the second point. Okay. Now the second point says, first let's forget about second point. Now let tell me that here we considered logarithm of x to the base a is giving b. So a raised to power b is x. So now let's now tell me for 2 raised to power any value, will it ever become 0? Can it be 0? So any value of 2, any value of 2, any real number, any real value of 2.
No, sir.
No, it won't. It won't. So what in this condition, what we are asking for, like what we are asking in this logarithm function for 2 raised to power any value, it will never become 0 because so what is its logarithm expression? It is logarithm of 0 to the base 2, and this is what we are finding. So this is meaningless because there is no such value exist. So that's why if our a is this here and the power was b and this was x. So that's why this is meaningless. So 2 was a, 0 was x. This is also meaningless. Second point stays true. Okay, understood? Clear or should I repeat?
Sir, could you repeat it again?
Yeah. So first, logarithm of x to the base e. Let's consider this is giving some value b. So what do it means? That a raised to power b is giving us x. So this is what we are discussing about. Now you have to tell me for any value for let's take any base. Let's write it as a only. For any value of for any power of a, will it ever become 0? Will it become 0 for any real value of this power? Will it ever become 0?
Mm-hmm.
Even if you take e raised to power 0, it is,
1.
yeah. So it's not, it will never become 0. So that's why this equation does not stays true. So we can tell does not stays true. So it is a meaningless task to find this. Okay. To find, I have written the power as an expression of question mark. So how question mark can we find out? By taking logarithm of 0 to the base a. So finding the question mark, finding the power of a so that it becomes 0 is a meaningless task because it's just not possible. So that's why we have written here that logarithm of 0 to the base a is a meaningless thing. Now understood? If not, please ask.
Mm-hmm. No.
No. Should I repeat?
No, sir. I've understood.
Understood?
Yeah, sir.
Yeah. Yes, what about Tanish?
Yes, sir.
Understood?
Yes, sir.
Yeah. So let's now discuss the next property. Okay, let's discuss it on the next page. So the next property says logarithm of x to the base a exists if and only if x is greater than 0, a is greater than 0 means they are positive real numbers, and a is not equals to x. So that's we have already discussed that a should be positive and x should be positive, and the only condition you have to once more like whichever variables are there in this logarithm function should be positive, and the base should not be equal to 1. So remember it like that. In logarithm function, whatever is visible to you should be positive, and the base should not be equal to 1. Clear? This is how you have to remember this. Okay?
Yeah, sir.
Yeah. So let's move on and discuss the property of logarithm. So before that, let's do a simple exercise. 2 raised to power 5 is
2 raised to power 5.
ah,
32.
no.
No. 2 into 2 into 2. Oh. Hmm. Sir, isn't it 32 to raised to power? You want me to say in the log form?
Okay, you said 32.
Ah, yes, sir.
Okay, oh, sorry, I misheard it. You said that 22. Okay,
Okay.
sorry.
32, sir.
Yeah, 32. What will be 3 raised to power 4? Okay, leave it. Let's discuss it first. Now, I want you to represent this expression, this equation in logarithm function, that how logarithm function will be applied here, and what is 5 equal to here. How 5 can we find out? Hmm? So let me do it for you. We will take logarithm of 32 to the base 2. Then its answer will be 5. That we are finding that 2 what raised to power 2, that what power of 2 should be raised so that it becomes 32. So this is what logarithm function is answering. The inputs are 2. That inputs are 2. One is the base and the other one is the answer, the like the exponential answer, and its answer will be in the form of power to what the power was there. Okay, so now tell me 3 raised to power 4 is what?
81.
Yes. Now how we can represent it in logarithm method?
4 is equal to log 3, 81.
Log 3 should be written where?
Down.
In the base.
In the
It is
base?
10 raised to power 3 is what?
1000.
How we can write in this particular exponential function in terms of logarithm?
Um, log, then 10 in the base, 1000, which is equal to 3.
Good. 10 raised to power 1 is 10.
Mm.
Log 10, log of 10 to the base 10 is equals to 1. So this is basic understanding. Okay. Now,
Yes.
great. So revising. A should be positive, M should be positive, and the base should not be 1. These are 3 conditions, okay? For logarithm function to be defined. Let's move forward. Now, the first property says that a raised power logarithm of x to the base a is x only. And why so? We will prove it after discussing the further logarithm properties. Okay. So that next property is base change property, where a is raised to the power of logarithm of x to the base b, and it can also be written as that x will exchange position with a simply. And please mind the conditions. All the conditions are derived uh, from uh, from considering the logarithm from for making logarithm function to be a defined function. That a should not be 1 and a should be positive. A cannot also be 0, because if it becomes 0, then whole thing will be meaningless. Okay. So let's discuss this later. Let me first tell you from my knowledge. Let me tell you from my notes. Properties of logarithm. Very important. Okay. So before discussing the logarithm properties, let's discuss their graph once. Okay. Let's discuss the graph logarithm first. Yes, here it is. So what does it means? What does it means? Please tell me how we will represent this logarithm function in terms of exponential function.
Hmm.
A to the power
A to the power y, which is equals to x.
ah. So this is the graph of y of logarithm of x to the a. Now a we discussed earlier, a should be positive and a cannot be 1. So if we draw a number line from 0, 1 to positive infinity, real number line. So a cannot be 0. So all the values from to the right hand side are possible. But a cannot be 1, there is a node. So this is a period. There are 2 different periods now. A can belong to a should be less than 0. So sorry, should be less than 1, should be greater than 0, but it cannot either be 0 or 1. So it should be lying somewhere in between 0 and 1, or a can also be greater than 1 simply. And sorry, yes, right representation. A should be greater than 1. This can also be, these 2 possibilities are there for the base a. Okay, and a should not be 1. There is a node. Okay, so now for this particular period when a is between 0 and 1, the graph logarithm is this. For this particular period of a is base, the graph logarithm is this. This point is 1 0, and this point is also 1 0. Okay, so in this, when the base is between 0 and 1, the graph as per positive y is decreasing. It's going down. The value of y is decreasing. And when the base is more than 1, with increase in x, the value of y is increasing. With increase in x means when we are going to the right of the origin, the value of y is increasing. Then the value of y, like let's say from here, if we go further in the x, then the value of y is increasing. Okay. The
Yeah.
value of y is increasing. The value of y is increasing. So that's this is the good thing about, and that's the special thing about logarithm graph. You need to remember it. And why it is happening so? Why it is happening so? Because let's take an example. If a is half, okay, if a is half, and we're discussing about half raised to power y, because a raised to power y is equal to x. Half raised to power y. Oh, please write. So now we will represent this exponential function to the base a being half, which lies in period of a is lying now in the period of 0 to 1, and it is not either 0 not half, not 1. So half raised to power e raised to power is equals to x. Half raised to power y is x. Now we have x and y only variables in the equation. Now we can easily draw its graph. Okay. When we'll draw its graph, for x is equals to 0, y will be not defined, because for any value of anything, it cannot be become 0. Okay, except the base is 0, but the base is half here. So for any power of half, it will never become 0. Are you able to understand this? Is this point clear?
Yes, sir.
Yeah. So if y is not defined here, so the graph will just not meet here anywhere. So the graph will tend to infinity on this point. On the next point, let's take on x is equals to half. On x is equals to half, y will be, come on, tell. For x is equals to half,
Um,
y will be, array, for
y.
x is equals to half, y will be, now what is the power of half here? 1. So y is what?
Then y is 1.
Yeah. So here, for x being half, this point, on this point, x being half, y is 1. So that's how the function, sorry. I did a mistake in drawing the graph. There will be, oh. So now let's again draw the graph in next page to be better. This is the y-axis, this is the x-axis, and half raised to power y is equals to x. Y is logarithm of x to the base half. So if we'll take x is equals to 0, y is not defined, so we do not know whether it is here or here. Okay, so now for x being half, let's consider this is 1, this is 2, 3, so x will be half here, somewhat here. So for x being half, y is 1. y is 1. So 1 point we have got. For x being, let us say, for x being 1 by 4, y will be 1 by 4 is half square, na? So y will be 2. In this case, y will be 2, y was 1. So for x being 1 by 4, 1 by 4, y is becoming 2. So now we got to know that the function is, the curve is going somewhat in this direction. So it will be positive of infinity on the origin. Okay, and the graph is going like this. For x is equals to 1, for x is equals to 1, it means that x is equals to 1. So half raised to power y is equals to 1. So when anything raised to power 0, a raised to power 0 is 1. So similarly, half raised to power 0 is 1. Right? Now y is what?
Then y is equal to 0.
Yes. Are you able to understand this?
Yes, sir.
Great then. So y will be 0. Y will be 0 here. X is 1 here. So 1, 0. So the graph will meet this, and similarly we can draw the remaining graph as like this. And similarly, we can also draw the graph of this. Okay. So when the base was less, y was getting decreased because the base is less than 1. So it's like a spiral. When we talk in life about positivity and negativity, so if the base, if it's about, like, there are good things and bad things in life. If we discuss good things over and over again, means we are giving more and more power to good things. So the goodness, overall goodness, will increase. How we will give power? By frequently multiplying goodness. How we will multiply? Because we'll keep on repeating the goodness or good things about any person, any process, anything, whatever is happening. So goodness overall will increase. Correct? When we'll keep on giving power to bad things, we'll focus on bad things. So the bad things will keep on increasing. So overall goodness here will decrease. So it's like the base of a is less than 1 and between 0. So here the base of a, the base which is more than 1. So when the base is more than 1, so the power will itself, when we will give more power to it, it will itself increase. There's one more example in the book Atomic Habits, and I'll give you an assignment for this. That in this book, there is a concept told that if we improve ourselves by 1% daily, and we can change ourselves 1% daily in either both of ways. We can also do it negatively. We can also increase. We do it positively. So if we will improve ourselves 1% by 1%. So if we were 100%, let's say, if we have raised 1 to the 1%, what is its 1%? 1 by 100, right? So 1.01 is the new day outcome, the tomorrow's outcome. And if we do it continuously for 365 days, there will be some magical number here. And if, let's say, sorry, I've written it otherwise. It should be here because we are improving ourselves 1% daily. And if say that if we decrease our quality, if we will not improve ourselves, and if we decrease our quality of life by 1% daily, so 1 becomes 1 minus 1 by 100, so it becomes 0.99, right? Right? So if we were, let's say today and tomorrow, if we are 1 today, so tomorrow will be, if we will improve, so will be 1 point, if we will improve by 1%, So it will become 1.01 if we'll decrease our quality by 1%. So it will become 0.99. Okay. So if we repeat this process of decreasing our quality for entire year for 365 days, there will be a disastrous number here. Okay. So this is your assignment, and you don't have to calculate it by pen. Just go to Google, be smart, and calculate it, and tell me in the WhatsApp group. Okay. So this is also a life lesson about how powers, how like they both are immense power here. Okay, we are applying immense power here, 365 days. That's immense power. But on what that matters, but on what? Whether it is whether we are improving it daily or whether we are decreasing it daily. So that depends. Okay, so there is immense power in both of these things because the time is powerful. So that's another thing. But my point behind telling you this, that when you will find out their value by using Google, you'll be surprised to see how 1% improvement can change you and will almost multiplies you over 20 times. Okay, you'll have to calculate that. Understood? Understood the analogy? Hello, mic test. Okay, let's move ahead. So example number 1. No, before that, properties. Very important properties. Very important properties. So logarithm to mn. Logarithm of mn to the base a can be rewritten as logarithm of m to the base a plus logarithm of n to the base a. That's a property. Okay. So taking an example, logarithm of 6, it can be rewritten as logarithm of 2 into 3 to the base 10, and then it can be further rewritten as logarithm of 2 to the base 10, logarithm of 3 to the base 10. This is one example of this property. Another property says logarithm of a, m is getting divided by n. Logarithm of m getting divided by n to the base a can be rewritten as logarithm of m to the base a minus logarithm of n to the base a. Okay, so now example of this is logarithm of 6 can be written as logarithm of 10, 6 by 1. So it can be written as logarithm of 10, 6 minus of logarithm of 10, 1. So its answer is basically what we are questioning here, to what base, to what power 10 should be increased to become 1. So we simply know a raised to power 0 is 1. So when we'll make its power 0, it will be 1. So basically it's 0. It becomes equal only. That was just an example. So these are two properties. Are you with me? Take one more property. Logarithm of m raised to power x to the base a. The power can be written here in the multiple. The remaining will be here. So what we have done, we've taken x in front of it. We have multiplied the power of the m to the logarithm of m to the base e. Understood this? Let's take some example. logarithm of 10, sorry, logarithm of, let's say, 1000. How will solve it? Logarithm of 10 and 1000 can be written as 10 raised to power 3. So now 3 can be rewritten as like this, 10 to 10. So now what is this? This is 1. Why? There's one more property, logarithm of a to a is 1. Simply because what is this questioning us, that a raised to power what power we should raise the power of a to become a only. So what power should be there? Infinity, simply 1. And there's one more important property, that logarithm of 0 to the base a, it should be no, no, logarithm of 1 to the base a is 0. So it can be rewritten as a raised to power 0 is 1. Okay, so these are two simple little properties which are very basic. Understand that. It's crucial for you to understand. Okay,
Yes, sir.
where were you?
Sir, here it's raining every time, single time, even your voice is breaking down.
Okay.
So I
What?
just I want to turn off the internet like that and all every time.
That's all right. So these are some basic properties which are driven from the fact that a raised to power 1 is a. So it can be a raised to power 1 is a. A raised to power 0 is 1. So it can be re-understood in the form of logarithm function as in this properties. And same goes for here also. And there's one more property, logarithm of m raised to power x. And if there is power to the base also, then what we'll do? We'll multiply the power of this. We'll get it's divided by the power of the base. Now it is presented as logarithm of m to the base a. And its example, let's take one more example here. Logarithm of 10,000 raised to power 10 and to the base square root of 10. So it is simply this, logarithm of 10 raised to power, please respond. Logarithm of 10 raised to power 4.
Oh, because
And
4 zeros.
to the base logarithm of uh, to the base 10 raised to power
Let's go.
half.
One.
So we will multiply this in front and whatever is there will get divided. And what is remaining? Logarithm of 10 to 10. So if both are same, so it will become 1. Now remaining is 4 is getting divided by half. 2 will get multiplied in the numerator part. 8 is your answer. Okay, understood?
Yes, sir.
Yeah. Let's now discuss more properties. Now let's come on to the more complex properties. Now it says that a raised to power logarithm of x to the base a. Now its answer will be, let's calculate what its answer will be. So it's how should we understand it? First, before that, there's a very important row property, very basic. Logarithm of let us say b, logarithm of b to the base a can be rewritten as, it can be rewritten as logarithm of b to the base e. divided by logarithm of a, which was base there. Now it has become the, like, it has come as the exponential result to the base e. What is e here? E is a
Napier's
Napier's
constant.
constant. Yeah. So can anyone of you can tell me what is natural log?
Don't know, sir.
It is the same. Natural log means that whenever we are taking logarithm of anything, let's take x to the base of e. So this is known as logarithm, natural log. And generally, we can also take some other values as its base. Okay. And in that particular form, that will not remain as natural log. But most generally, the base is 10. Generally, we learn about logarithm of 2 to the base 10. We learn logarithm of 3 to the base 10. So all these values will also be provided you in the table format. You have to learn for only of 2 is enough, of 2 and 3. That would be enough. These two values will be enough. Let me download it. Okay, let's do it later. First, let's understand the property. So this is very important, that it can be rewritten as in this format. Okay, this is natural log. Okay, most of the times e is taken as granted, so it's not written even logarithm of x directly because it's taken granted. If there is nothing in the base, then there will be e. Okay.
Yes, sir.
Yeah. So now let's discuss this property. It is saying that when a raised to power logarithm of x to the base a, then it will be written as x itself, where a should not be 0 and a should not also be 1, and x should be positive, not be 0, of course, should be positive. So this is the property. Let's take an example. 2 raised to power logarithm of or logarithm of 32 to the base 2. So on finding out, logarithm of 32 is what? 5, right?
Sir.
So 2 raised to power logarithm of now the 5 will come ahead the multiple. Okay. Now remaining is logarithm of 2 to the base 2. It is what? It is what?
1.
Yes, 1. So now what is remaining? 2 raised to power 5 into 1. 2 raised to power 5, which is what?
32.
32. So the answer is this only, right?
Yes, sir.
Yeah, that's why its answer is coming as x also. This is one example of this. There's one more property. A raised to power logarithm of x to the base b. Okay. Now it is saying that we can exchange the position of a and x. It can be written like this. Okay. So this is exactly what it was saying, that we also did exchange the proposition. Let me explain it. Let's take an example. 2 raised to power logarithm of 2, 32. We know its answer is 32 itself. So if this condition is true, if this property is true, our answer will also be the same. So we'll change this position by this. So 32 raised to our logarithm of 2, logarithm of 2 to the base 2. Now what is this?
1. So
Yeah.
it's
32 raised to power 1, it's 32.
Hmm.
So our property stays true. So these two property are very important. They're written here. Okay. We can exchange the position, this position and this position, this position and this position. Okay. Earlier when we were doing it, so the x raised to power logarithm of a to the base a is becoming 1. That's why it is not mentioned here. But here, logarithm of a to the base b is not becoming 1. That's why it is written. So basically, it is the same property. This one is the principal property, and this is just in the first property is just in derivation of the first second. But still, we need to remember the both, and they are very simple. Okay.
Yes, sir.
Yeah. Third property we have already discussed. Logarithm of a to the base a is 1. Logarithm of 1 to the base a is 0. This is just another manifestation of writing a to the power 0 will become 1 given that a is not 0. Okay. And whenever we are writing any logarithm function and there are two variables, then both of the variables should be positive. Both of the variables should be positive and the base should not be 1. Yes, these conditions must always satisfy to define logarithm function. Are you with me?
Yes, sir.
Yeah. So this property says here, let's derive this property. Logarithm of x a. What now how we can write it as logarithm of x divided by logarithm of a. Correct? Correct?
Yes.
We can also write it as logarithm of a divided by logarithm of x. Correct?
Yes, sir.
So what we can write this as logarithm of a to the base x. Okay?
Yes, sir.
Yeah, and now this is the property that we have changed the base and we have brought the whole logarithm function in the denominator part. Understood?
Yes, sir.
Okay. Now this is saying this is simple. This is very simple. Okay. So if we'll open this, logarithm of x divided by logarithm of b multiplied by logarithm of b divided by logarithm of a to the base e. These all have bases e. I'm not writing it. So this will cancel this. This is again become logarithm of x to the base e to the base a. Understood?
Yes, sir.
And when we will open this, so this is what logarithm of x upon logarithm of b. This is what logarithm of a upon logarithm of b. So again these are getting cancelled and again it's becoming 1. Okay.
Yes, sir.
Understood?
Yes, sir.
Okay. So now this property's importance is this, that when we are discussing about any logarithm, so we can introduce them to the base of anything else also, anything of our choice, of our convenience, b's of our convenience, but only one condition, that b should be positive here. Okay. Now
Yes,
let's
sir.
take an example, that if we are discussing about logarithm of 100 to the base 25. Okay, so we can introduce another base 100 to the base 10 and also the same in the denominator. Okay, now it's convenient for us because we know its value, it is 2. And about this, so 25 can be written as 5 raised to power 2, 2 into logarithm of 5 and 10. And we also know about the value of logarithm of 5 to the base 10. Generally we know it. And even if we don't, we know the value of logarithm of 10 or logarithm of 2 to the base 10. So what we'll do here is simply write logarithm of 5 as 10 by 2 to the base 10. Let me rewrite it in the next page. To finding logarithm of 5 to the base 10 power, what will you do? Write as 5 as 10 by 2. So now using the property 10 by 10 minus logarithm of 2, 10. So this is 1 minus logarithm of 2 to the base 10. Now we know its value. Okay, that's how we will find it. Understood the convenience of this property, the use case?
Yes, sir.
We have already discussed these properties. Okay, and we have also discussed this property where there was power in the base. It was coming as in the denominator part. It's getting like divided, and when the power is here, the power will be multiplied. M is getting multiplied and is getting divided. So we have already discussed these two properties. Yes, this is important. This inequality is important. Okay, so may I erase everything?
Yes, sir.
Okay. So now this property is saying that, let's go back. To the graph. So there are two types of graph. We are exceeding time. So let's discuss the next property in next class, okay? Okay?
Yes, sir.
Yeah. So please make sure to go through the notes of today's class and make notes and keep on brainstorming about logarithm, read your books, read your NCRT, and solve questions. If any doubts, please bring it to the WhatsApp group or to the class tomorrow. Okay.
Okay, sir.
Thank you. Good night, Jai Hind. Sorry. Good evening.
Yeah. Thank you, sir. Jai Hind.
Change.